This is the charge balance activity which goes with lesson 12. In this lesson you've been teaching about how to calculate the net charge on an ion after it ionizes. This activity will give your students a more concrete way of thinking about how this process happens. To construct a charge balance, we've just taken a toilet tissue tube and then with a rubber band I've affixed it to a ruler. I've then taken two styrofoam cups, and this can be any sort of cup, and then just with a little bit of tape secured it to the ends of my ruler. Then I'm going to take a marker and identify on my cups what I have. In one cup I'm going to put a plus sign for the proton side, and then on the other cup I'm going to put a minus sign where we're going to be depositing our electrons. Now you might want to tell your students that you haven't constructed this balance to do any actual weighing out of any protons and electrons. It's just a way to show when we have an extra of one or the other. So the balance, you can do your best to make it pretty much balanced when nothing's in it, but that's not an important factor here for this demonstration. Ready? The next thing I'm going to do is we're going to use milk caps here, and again you can use anything if you have some counters or some chips or little discs of any type. Pennies will work, buttons will work too, as long as you have a supply of each. I've got some yellow milk caps here, and then I've got some blue ones here, and I'm going to take a marker, and on these I'm going to just to make things totally concrete, I'm going to put plus signs so that we'll know that each of these yellow milk caps represents a proton. Now I've got about 12 of these, so it depends on how high an element you want to do in your demonstration. So I'll just go ahead and we'll finish these. These are all plus signs for protons. And then I'm going to go to my blue set of milk caps, and we're going to put negative signs on these to represent our electrons. To use our charge balance now, we'll start with an example, and a good example I like to start with is the simpler ion like lithium here. We'll start with lithium. Now lithium is atomic number 3, and so in the neutral state, the non-ionized state, it's going to have its 3 protons. So we'll go ahead and we'll deposit 3 protons here on the plus side, and then it has those 3 electrons. 1, 2, 3. Now if we had a perfect balance, we could show that yes, those two do balance each other out. Now go back to your periodic table with your students and ask them, well, how does lithium ionize? Or you can ask them, how many valence electrons does lithium have? And hopefully at this point your students will readily say it's got 1 valence electron. It's got 1 valence electron. It would like to lose that 1 valence electron in order to take on the configuration of helium here and be stable like helium. So if we start with lithium, it wants to ionize by losing 1 electron. So we go back to our charge balance here. Lithium will ionize by losing one negatively charged electron. So we're going to take that one out, and then if we let it go, of course it should tump to that side, and to show that we definitely have an excess now of positively charged subatomic particles here. So then what you can do is take those out, and you can stack them up side by side to show how indeed we do now have an excess number of positively charged. And you can ask your students, well, how many more positively charged ones do we have than the negatively charged? and hopefully they can readily see, well, we've got one more on the positive side than we do in the negative category. And then on your pad is, we can say now, well, when lithium ionizes, so the symbol is Li, and when it ionizes it has one more positive charge, so we're going to be Li with a +1 charge. Okay, let's take a look at another example now. The element I want to look at now is fluorine. Fluorine, when fluorine ionizes, it'll become fluoride. So if we find fluorine right here, atomic number 9. Fluorine is atomic number 9, so we should get 9 protons. So we'll go 9 protons, 2, 3, 4, 5, 6, 7, 8. There's our 9 protons. And then on the electron side, we'll do the same. 2, 4, 6, 7, 8, 9. So we have an even number. And if our balance was perfect, again, it would just be nice and balanced there for your students to see. Okay, now we're going to go back to the periodic table, and we'll talk about fluorine now. It's a halogen. It wants to gain 1 electron. Halogens have 7 valence electrons. They want to have 8, like a noble gas family. So if it can gain 1, it'll look like neon and be totally happy, totally stable. Alright, so the fluorine is going to gain 1 electron. So if we go back to our balance now, it wants to gain 1 more negatively charged electron. So we're going to go ahead and deposit it right in there. We let go of the balance. We'll see. Whoop, yep, we definitely have more on the negative side than we do on the positive side of our balance. And then, like we did before, we can take them out. Let's stack them up here. Now you can lay them out flat like this, depending on what type of objects you're using, or you can just stack them up tall. If you've got blocks or something like that, pennies or something, you can stack. I'm going to see how far I can go here. How many we have? 1, 2, 3, 4, 5, 6, 7, 8. I can get one more. Here's my 9th. And then we're going to go on the electron side. So we're just going to park them right next door. There's 2. We've got 3. There's 4, 5, and 6. 7. There's 8 and 9, and fluorine added 1, so we'll have 1 more in our cup here. So now we have 10 electrons when it ionizes, and again we can see, I'll bring this down a little bit here. Again we can see we definitely have 1 more on the negative side than we have on the positive side. So when we go to write our symbol and charge, we're going to say F for fluorine, and it's got an excess number, so we're on the negative side, so it'll be negative, and it's got an excess number of 1 here, 1 extra on the negative side. Now if you do have students who have had experience with negative numbers, you can go ahead at this point and say, well, we've got 9 on the positive side, and we're going to add it to a negative 10. So a plus 9 added to a negative 10 does equal a negative 1. Okay? Or 9 take away 10 equals a negative 1. Alright, so this is the charge balance. It's a concrete way of showing your students how you can compare the positively charged protons to the negatively charged electrons, and then be able to count and see, well, how many do I have extra either on the proton side or on the electron side once that neutral atom ionizes.